Okay, we have energy and bonding, or energy and bonding. So let's talk about this and what's going on with energy and bonding. In an exothermic reaction, energy can be written as a product in the chemical equation. During the reaction, energy is released to the surroundings and the temperature of the reaction container increases. Okay? So then the explanation as follows. Exothermic reactions release energy to its surroundings. The prefix exo means outside. It means that they release energy on the outside. Okay, let's go to the next part. Bond energy, potential energy. Energy possessed by an object as a result of its internal state or its position with respect to other objects. Okay. Potential energy in chemical bonds, unstable and stable. Simulation, we can take a look at this. Distance between atoms of what's going on here. Here's just how they go bounce back to each other. Bring it here, and then watch it roll back. Oxygen's slightly different than this. Neon's a little different as well. So as you can see, it's a little bit bigger. Okay, let's go to the next part. Bond energy. The average required energy per mole to break a particular type of bond between atoms of particular element. Okay, bond energy is the energy added to bring potential energy of atoms to 0. This just gives you a couple examples. Bond length, distance between the nuclei of 2 atoms in a molecule. Okay, let's see what's next. Energy and chemical reactions. This just kind of talks about energy and chemical reactions here. It kind of goes over, let's see, just a couple examples. Exothermic reactions, chemical reaction that releases energy. It just shows you what happens when it's releasing energy on the outside. Here's what's going on during the process. Endo, if you recall, means absorbing. Exo is releasing, endo is absorbing. Activation energy, the minimum amount of energy needed to start a chemical reaction. Go to the next part. Endothermic, remember, absorbs energy. Here's what happens when it is absorbing energy. Okay, next part. The internal energy of a system plus the product of pressure and volume, a change in enthalpy equals the change in the internal energy plus the work done by the system. So enthalpy of reaction, change in enthalpy of a system due to the chemical reaction. And you have a bond of energies here, table of bond of energies. It just shows you a couple examples right there. Ask an astronaut, well, watch that on your own. Bond energies again. Looking it up just kind of gives you some more examples. Kind of goes through, gives you a few more examples here. Catalyst, it goes through. Catalyst is a substance that speeds up a chemical reaction but doesn't react itself. So a substance that lowers the activation energy of a reaction but otherwise is not part of the reaction. Without the catalyst and with the catalyst, like what happens if you use it or don't use it. Again, here's just a couple examples with catalysts and what is going on, what's taking place. How does catalyst function in a chemical reaction? It reduces the activation energy for the reaction. So a catalyst make it easier for the activated complex to form, which reduces the activation energy of the reaction. Catalyst doesn't change energies of the products or reactants, so it doesn't affect the enthalpy of the reaction, change of reaction. Enzymes, substance that acts as a catalyst for chemical reactions in living things. Okay, so how do enzyme functions function in biological reactions? Well, enzymes function by providing a shape that allows reactants to combine more easily. So enzymes hold reactants in place, lowering the activation energy by speeding up the formation of the activated complex. Hopefully that gives you clears everything up for you.